Hello everyone, welcome back to the one more session of multimedia systems. So we were discussing about the topic called the optical storage media. In the previous session we had discussed about the limitations of CD-ROM technology, the CD-ROM XA, that is the extended architecture. Under the CD-ROM extended architecture we had seen about the two variants, that is the CD-ROM XA with respect to mode 2 and the form 1, and also CD-ROM XA with mode 2 form 2. So we had seen the both architectures with the diagram, their differentiation, and how the bytes or information are being distributed with the two forms. And also we have seen about the compression of data with respect to different medias. And finally we had discussed about the different medias, that is variants of compressed media forms with respect to the examples. Now in this session let us start with the CD-ROM based development. So before starting with the CD-ROM based development, most of the optical storage media from the beginning till now, the CD-ROM specification has been held as a basic specification. Under the standard specification of the CD-ROM, latest and the different versions have been emerged keeping the same specification as a standard. Let us look into that. The interaction of the different CD technologies is shown in the diagram. Look at this diagram. We were discussing about the initially with respect to CDDA, that is data CDs. So that is been derived with the CD-ROM 1, means CD-ROM 1 technology provides a basics for many things. Under the CD-ROM we have two modes, that is mode 1 and the mode 2. Look at this. So they undergo the ISO 9600 specification, means it has its own standard, means it has been approved standard. So this standard is been used entirely with respect to the CD technologies. Now coming up to the CD-ROM extended architecture, means after the CD-ROM the new technology that has been emerged was CD-ROM XA, that is extended architecture, where again it comprises of two different forms. One is form 1 and the form 2. What is form 1 and form 2 with respect to CD-ROM XA and mode 1 and mode 2 of CD-ROM has been already discussed in the previous sessions. Look at this. So form 1 and form 2 are totally derived with respect to only mode 2 of CD-ROM. So a particular arrow has been pointing only towards mode 2, means CD-ROM XA uses only mode 2 of form 1 and mode 2 of form 2, and CD-ROM totally has two forms, mode 1 and mode 2, and here CD-ROM XA is also associated with ISO 9600 standard, whereas CD-ROM is also associated with 9600, so which has been derived with respect to a CDDA. This is how we talk about the CD-ROM based development. So completely for every aspect CD-ROM technology has been provided the basic specification. Let us look into the one more new thing, that is compact disc I, that is interactive. Next concept. It is called compact disc interactive. It is represented as CDI with a capital letter. What is the difference between the previous version and this version? This is also developed by NV Philips and the Sony Corporation. Now you can know So in most of the development of the CD with various variants, so NV Philips and Sony Corporation has its contribution a lot. So this is the importance of these two persons, one person and the corporation. Next, it was announced in the year 1986. Okay, it is a very old version. Now when we talk about CDI, originally it was designed for consumer electronics. When you talk about consumer electronics, it is for mainly the end users. Means in addition to TV, the one more device was given, like what you have the CD players or a DVD players. That was the concept at 1986, which was designed. CDI should be a device like that, accessories that should be given along with the CD, or people should have, consumer should buy it as an accessory in association with the TV. So that was the intention of having CDI, and it was produced to the market during 1991. Means this was announced in 1986, and the concept to be used as a consumer market came into the reality only in 1991. Means but the year 1991 it was given or produced in the market so that end user can take it as an accessory and plug in with their television and use it for the CDI. And it did not become much popular, though it was given with the intention of consumer end product. It did not become much popular, but it ruled the countries on the period till 1997. Means till 1997 people were using it, but day by day it started losing its popularity. By end of 1997 it was totally lost its familiarity or the popularity. What is the reason? The reason is the lot more things. We'll go to it one by one. It includes the CD-ROM technology based format, but with the interleaving of various variants. That was a positive nature, but the thing was this interactive CD has a complications things. What was the complications? It did not match with every devices which was already available in the market. Means it had a compatibility issues. What do we mean by compatibility issues? When you talk about compatibility issues is that the manufacturer of one CDI was allowing only a particular kind of CDs to be played on it. The other CDIs or other CD-ROMs were not played with the same devices, or different variations or versions or variants was not played in all the devices. That was the major drawback. And the Motorola devices, company you might be knowing about the Motorola. Motorola came into the existence at this time, during which they contributed with respect to a component called the decoder with their main boards. So they used the decoder in the hardware component, which was called Motorola 6800. And this component was suitable for only particular devices. So all the devices were not having this Motorola 800 component, which was again a drawback. Means there was a problem with respect to the compatibility issues. Only the devices, the hardware devices which were associated with this feature were supporting with the playbacks. So after 1997 it was totally losing its popularity, and it was also included with the CD player. Means this component was included with the CD player with a controller and a joystick or a mouse. Means now what was happening here was, during this period they also, to make it popular, this device popular in association with the TV, this player was also given with the joystick kind of thing, where it can be rotated, or it can be button kind of thing, where small button with a small joystick was given, where the options or operations can be performed by selection or variation or selecting a particular option, menu. All these things were option was included during this period, and it was the same size of video decoders or video recorders. It was not much big. At those days the video recorders or video decoders was as big as a A4 or a double sized book size, and the thickness was much more bigger than. So this was about the CDI. Now when we talk about this origination, let us look into the concept of audio coding with respect to CDI. How was the audio information was stored, other things we will be looking into it. What we call it as audio coding. Now we are talking about the audio coding with respect to CDI. It includes different quality levels with different capacity and data rate. Means, whereas quality levels were different, also the capacity and data rates were also different. So this was the importance that we look into the CDI. So there are different variants where it includes the different quality levels with different data capacity. When we talk about data capacity, we have seen in the previous session the chart where we see the different data rate, the frequencies and the capacities of that CDs. In the similar way, this audio coding involves different quality levels, and also the capacity varies, and also rate of data transfer is also varying, and different mode, means the CDDA audio A. Now it has with respect to audio A, B and C modes. Means it has three very different modes, that is CDIA with respect to A, CDIB, one mode, CDIC. The three modes were supported. That's why we call it as different levels. Each mode has its a different quality level, different capacity, and obviously data rate transfer is totally different with three modes. It has a very close relationship between CDI and CD-ROM XI. This CDI, we are talking about totally CDI, it has very close relationship with the CD-ROM and CD-ROM XA architecture, means it has been derived from that. So obviously it has to be very closely associated. The CDI totally uses the concept of CD-ROM XA to a greater extent. Means though it has the standards of CD-ROM, the specification of CD-ROM XA is been inherited in a greater extent. Next, the lower data rates can be used in a combination with images and motion pictures. Means we talk about the data rates. So when the lower data rates are there, it was possible to combine images with the motion pictures, means a combination was able to achieve in CDI. So multiple channels with the lower quality was supported, means the huge number of combination capacity was done with lower channel of audio and motion pictures, images with other rates, means different data rates have been tried in this version. Means the people started using the transmission medias, different data rates was available, so they use with variations of data rates during the transmission. That was very much supportive with respect to the audio coding. A greater chart is there where it uses the sampling frequency, bandwidth, coding and the data rates and the number of cycles that was accessed at per instance of time, and also the portion of the data, and finally the quantization or the quality that was achieved. So all these things should be represented. So for each mode, CDIA, CDIB and CDIC, it is totally different, and that chart can be seen in the picture. Next, when we talk about the coding of images, this was about the audio coding. Now when we talk about the images, why are we talking about audio and video now, images? Now the CDI supports this. The lower bandwidth or lower data rates also supports the combination of audio and video images. So that's why we saw about audio coding. Now we are seeing about the coding of images. CDI can be used to code the images of different quality levels and also with respect to different resolutions. So that is why we have 3 modes. So there are different resolutions, different quality, different data rates and also capacity. So this is the plus point here. So different quality levels and resolution can also be achieved. The chart explains the following. The first thing is, the first property that we look here is the YUV mode. What is the importance of YUV mode? Where if you want to use the reproduces the images which are natural with many colors, then YUV mode is used. Means this mode is used to represent natural kind of images. You might have seen many times when you take up an image in the mobile cameras, the images look so beautiful, but it would be totally different from the natural things. Suppose you consider there is a flower, okay, it looks very beautiful, but when you take an image or a photograph of that image, mobile phone, it looks much more beautiful, but it is not in the real actual image, is totally different from the captured image. Why is that? There is some kind of image processing happening. What is that image processing happening here? Means the image processing application in the mobile enhances the color and also the light on that image. So it beautifies the images. Now, so we look into that aspects here. The image resolution here is 360 into 240 pixels. Now, this YUV uses 360 into 240 pixels. The luminance factor, what is this? These two, Y is called luminance. So you should look into the two components. There are three components here, the luminance and the chrominance factor. When you talk about luminance, what is luminance? It is nothing but light. What is that UV? UV is called chrominance. What do you mean by chrominance factor? It is nothing but color. So a totally image can be beautified or we can have a very good image based on these two parameters. So one is the resolution, that is true, that is we have in the YUV format 360 into 240 pixel per inch and a bit, and also we have two things, one is the luminance factor and another is the chrominance factor. Y stands for the luminance, that is the intensity of the light, whereas UV stands for the chrominance factor, that is two components. So what is this use? The total combination of YUV, all the three, uses 16 bits per pixel. Means YUV combination in total uses 18 bit of pixels in per bit. Means it uses in one bit 18 pixels are being stored, so in order to represent the importance. So we are having a very good image processing happening here, and it also stores 2,62,142 colors. Look at the color combinations available now. So it is almost having 2,62,144 types of colors can be represented per image. Means in an image this much of colors can be used. How these colors can be used? With the combination of light and color and the color combination, that is luminance and the chrominance factor. With this combination, so with the resolution of so much and using of 18 bits per pixel, we can able to get the data size of an image that can be represented as we will look into the how the data size will be there. Now what is the resolution? The resolution we have 360 into 240. How many bits per pixel? 18 bits per pixels are used into 1 byte by 8 bits per byte. 8 bits per byte are used. We want to convert it into bytes. So you are able to get an almost or approximately 1,94,400. Means the data size of YUV image format in CDI can be associated with this specification is almost able to achieve 1,94,400 bytes of information. This is with respect to YUV mode. Next, we will look into one more mode, that is we call this as color lookup table mode. This is represented in short as CLUT, that is color lookup table. What is the main specification of this? It works with 4 bit per pixel. Here in the specification 4 bit per pixels are used, and it is suitable for graphics for retrieval of using preloaded colors. Means it is mainly suited for graphics with preloaded . Means already the color combination is been already given, so there is no extra options of adding or manipulating. Exactly retrieving the similar kind of color or generating it to an image is very much suited in this color lookup table. Because why is that? There is a table called color lookup table. This table consists of n number of patterns of different shades with the number, so we can match with the exact color and retrieve that. That is the key point. Whereas in other things we need to manufacture or look into the process of processing the similar color, whereas here there is a set of color lookup table like a palettes of different colors. We can exactly match the shade and retrieve that color. So that is the importance why this is very much suited for graphics. And with 4 bits per pixel for almost 16 bits or 16 colors can be simultaneously represented. Means here 4 bits with respect to 4 into 4, 4 4s are 16. So 16 colors can be presented or permitted with a combination of these, and it has a resolution of 720 into 240. This is what the resolution has. Now, if this is the resolution, let us look into data size of an image. Now, what is the resolution? We know the resolution is 720 into 240. Next, how many bits we are using of 4 into 1 by 8 bits per byte. So that would yield the data size of almost 86,400 bytes of information. Means this kind of CDI image can store with this kind of specification, that is 4 bits per pixel, which supports the graphics with respect to preloaded the color combination, easy to retrieve exact kind of colors, and with a 16-bit permitted combination, and the resolution of 720 into 240 pixels of resolution, we are able to get the data size per image is almost equal to 86,400 bytes of information. This is about the second mode with respect to CDI, that is color lookup table. And the next is a RGB mode, the very famous concept. So in most of the color lookup tables, and after the color lookup tables, the best mode that is been used everywhere is the RGB mode. That is the third mode. Let us see the importance of RGB mode. Here, this was totally intended to have very high quality image output. The main intention of RGB is to produce high quality images. The main intention of having this mode is to have high intensity images. The red, green and blue components of each is coded with the 5 bits of information, means the RGB each is coded with 5 bits of information. So each comprises, or each bit is given with a combination of 5 bits of information. So when I talk about 555, it is 5 plus 5 plus 5, which is equal to 15 bits. Okay, but in this combination an additional bit is given. So 16 bits per pixel representation is achieved. So one more additional bit is provided in this technology in order to provide a best combination of colors, and it allows around 63,530 presentable colors. See, look at the colors combination. 63,536 different colors per image is permitted in this combination, and it uses a resolution of 360 into 240. Of resolution has been achieved. So if this is the specification, what would be the data size of the image? The first we will look into the resolution, that is 360 into 240 into what is the bits? It is 16-bit pixel. So we use 16 bits, and next we have to convert it into bytes, that 1 byte by 8 bits per byte. So what is the amount of achievable things? So we are able to achieve 1,72,800 bytes of information. Now while comparing to all the modes, the first one was a YUV mode, second was a color lookup mode, and third is a RGB mode. We have seen the specification and also the data size of each mode. Looking at all these modes, this mode provides a very good specification, very high intensity of colors with more number of color combination, and also data size is much more better when compared to all the 3 modes. This was about the CDI color images with respect to the coding of images. So we have seen about the audio coding, now we have seen about the video coding. Next, is coding of animation, means How does it support? Let us look into it. When we talk about animation, it's a combination, means it uses run length encoded format using approximately of 10,000 to 20,000. It uses run length encoding and 10,000 to 20,000. It's a huge thing. 20,000 bytes per images are being used here. We have seen this technology is very much supportive to the graphics and also animation. That's why we are dealing with this concept. So this is using with the run length encoding, which supports of 10,000 to 20,000 bytes per image, means the more number of bytes has been used, so we can have the property of graphics, that is a conversion of variation graphics to be involved, and also the concept of animation can be deployed with this format. And CDI will be using the MPEG video coding format, that is MPEG. Because we are talking about the animation, the graphic, there should be a continuous motion picture. So this CDI with respect to animation supports MPEG, whereas we have seen about the older versions, variants that was not making use of MPEG, or some of the versions was not supporting with respect to MPEG, that is MPEG format. Now this one supports with the MPEG, and it is strongly influenced by ISO 9600 format. That is 9660 format. So it is using the standard specification. So what one more thing is, though it may been used with respect to 960, it is not compatible with all the devices. That is one more drawback when we consider. So standard is being followed, that is true, but with respect to the compatibility with respect to devices, it's been not completely achieved, and CDI provides the basics of means this CDI would provide a basics for CD-ROM extended architecture. So some of the concepts were also been added from CDI to CDI XA in order to achieve the video concepts, because audio was very well suited there with respect to only the video issues was there. So that can be overcome with the concept of CDI. This was with respect to coding of animations. Let us discuss into the one more topic. The next topic that we are about to discuss is compact disc interactive ready format. Compact disc interactive ready format. So as the name suggests, something is ready already. So let us look into it. What this is which is different from formats. So when we talk about different from other formats, how it is different? Though all the CD formats are derived from the standard format of CD, that is CD-DA format. In the beginning of this session, I had shown you with the diagram where CD-DA was at the bottom, which was derived. All the other formats were associated or derived from that format, or all the other formats inherited the characteristics of CD-DA. Though there are a lot of different formats, CD-DA provides a stem, means through which all other formats are opened or introduced like a branches, though it might be a CD-ROM, CD-ROM XA, the CD-ROM I, and any other things. The CD-ROM DA devices were well connected with the CDI devices. And one more problem that we encountered here is the CDI had some issues. Because it was consumer oriented devices, it has a problem with respect to compatibility This is very much highlighted in the textbook. Though when we start with respect to CDI, so CDI totally supports many things and the plus point, but main thing is the compatibility issues. This was highlighted throughout the textbook in up to 4 pages of when we talk about the CDI. So when we talk about these things, there are a lot of specific formats. When we talk about specific formats, in order to overcome these compatibility issues, there came up the picture to have this one, that is compact disc interactive ready format. Means CDI was very good, supported graphics and animation, everything, but it has a compatibility issues. Though it was given as a consumer end product, it was supportive, but particular devices and particular CDI was not played in all the players. So in order to overcome, they had a one more thing that was introduced, that was CDI RF. We call it as compact disc interactive ready format. What is this? What was the information, or how did this thing overcome the compatibility issues? When we talk about these compatibility issues, here we have a track pre-gap. What do you mean by track pre-gap? Means every track, we have seen the information of tracks and sectors. At every track has a small gap at the beginning. So that gaps are used to show the index points. When I talk about index points, there we call it as index point 0 and index point 1 and so on. What are these? These are the initial points of the tracks. So what does this track information do? So these tracks information, what they did was, usually the track pre-grab information was up to, initial things was up to 2 to 3 seconds. It had only the pre-gap, means the starting gap. So after that gap, the exact information used to start, but it was only 2 to 3 seconds. What did they do? Here the gap was extended up to 182 seconds. Means from initial point 0 to initial point 1, there was only 2 to 3 seconds in earlier version. Now what they did is they extended the track pre-gap from 2 to 3 seconds to 182 seconds. Why did they extend? They did the extension in order to store the information in this area. What kind of information they stored? It included the details like individual pieces, images, biographics and everything with respect to that CD. So because every information was stored, it was something serving as an index. So it was able to achieve, and that device was able to transform its reading potential to read that particular data without the hesitation. When we say about hesitation, the switching of different formats was a problem in earlier cases. Now because there is a pre-track gap or track pre-gap of 182 seconds, which is much more higher in order to analyze itself, in advance itself, so that it is able to switch with respect to different formats. Now what happened? That players were able to play those medias. So this was the information about the compact disc interactive ready format. So that's why they made those CDI to be ready. Interactive ready means how this interaction happens. This is where the interaction happens. When this has been interacted, that disc has been made ready for the usage. So these are the information that I have wanted to share. While talking with respect to summarization, in today's class, we have discussed mainly about the compact disc based development, where different development modes was discussed with respect to CD-ROM mode 1, mode 2, with respect to CD-ROM mode 2 XA of form 1 and form 2, and also the compact disc interactive was completely discussed, where what are the feasibility and other things, and we have also discussed about the audio coding of the compact disc. What are the different forms of coding, how the specifications has been derived, and we have also seen about the various charts that is there with the CD-ROM I with respect to mode A, B and also mode C, and also various specification, and we have seen about the coding of images. When we talk about the coding of images, we have discussed about the first mode, that is YUV mode, the second mode, that is color lookup table mode, and the third one is the RGB mode, which is the most predominant mode. And finally, when we talk about the coding of animations, we have seen how the animations coding are very much supported in CDI. And finally, we have discussed about the compact disc read interactive ready format. We have seen CDDI had a compatibility issues. How do we overcome this compatibility issues and what made it to overcome? So just by enhancing the track pre-gap from 2 to 3 seconds to 182 seconds, this problem of compatibility issues was overcome. These are the things I had wished to discuss in this session. Thank you very much.